Thank you for joining us for our today's webinar, Scaling Traceability, How a Small Manufacturer Did It. I'm Shayna. I'm with the Pico marketing team, and today our presenters are our CEO of Pico, Ryan Kuhlenbeck, and Chris Stewart, manufacturing engineer for Pollington Machine Tool. I'll let them get started in a minute here, but before we do, I just want to remind everyone that if you have any questions during the webinar, please go ahead and put them in the Q&A down at the bottom. We'll answer those live if you have any questions that come in. And also at the end of the webinar, we'll have a really short survey that we'd really appreciate you filling out. So I'm going to hand it over to Ryan and we'll go ahead and get started.
Thanks, Shayna, and welcome to today's conversation. You've got two engineers here, so we'll try to not be shy and actually have a fun conversation and back and forth here. But our goal is just to give an example and a little bit more information on what it's like to transform a factory with a focus towards traceability. I have a pet peeve about a lot of the content that's out there where it doesn't go deep enough for people to follow along. So we're going to try to solve that today, as we usually do. So that being said, as Shayna mentioned, we received questions. These are some of the ones that we received in advance. So we're going to try to tackle these either during the presentation or we'll actually stop at the end as well and spend time to go through these and any other questions that get added throughout the day today. So please do use that. It's, we're here for you guys as much as anyone else. So with that being said, let's get started. Chris, you ready to go?
Yeah, I think so.
All right. Well, I'd like to introduce Chris Stewart from Pollington Machine. And Chris, tell us a little bit about Pollington and what you do, where you're located, things like that.
We are located in Marion, Michigan, which is kind of central northern Michigan.
There,
family,
right?
Exactly. Yeah. Not all of us from Michigan do that, but yes, that is an easy way to show. We're a job shop. We just primarily make parts for various manufacturers and customers. Family owned and operated since 1966. We have a handful of CNC machines. We are spread across automotive. We got aerospace, defense, energy, just different industries that we try to keep ourselves diversified. So we've got our fingers in a little bit of everything.
And you're in one of two quiet places in that factory, which is where right now?
Right now, I am currently hiding out in our one of our shipping and receiving offices.
I think many factories can relate to that as the only quiet place.
Oh, absolutely.
Okay, well, so you started this journey about 18 months ago with the launch of a new product. So why don't you bring us up to speed on kind of what you were doing and where you were starting from?
Yeah. So we originally, our foray into Pico was originally for work instructions. We were doing assemblies that required a lot of steps, and we were trying to make sure that we didn't miss any of the steps throughout the assembly process. Then we added in the hurdle of a non-English speaking workforce. So that added in itself more complexity to the just struggling to communicate a little bit, making sure that we covered every single step for the safe launch program that we were doing, that we had to build 2,000 assemblies without any problems at all, any parts missing, anything applied incorrectly. So that's where we originally started with Pico, was just a set of work instructions. And then we thought, okay, well, why don't we start adding devices in? Why don't we utilize some of Pico's traceability to monitor the parts, keep an eye on the parts, keep track of, okay, this serial number here was built successfully. And that was our first step into, I mean, everything was still kind of manually entered into Pico with, yes, we did this step. Yes, we did this step. So we're still relying on the operators to tell it, yes, I successfully installed widget A into part B.
And just to take a quick step back, this is like what, 6 foot long, 7 foot long chassis cross member with what, 30 pieces inside of it, something like that.
It's when fully assembled, it's closer to between 7 and 8 feet long. This one that's in the picture.
Yeah.
We have two different ones we do. That one being the larger and longer one, and then we had another one that was just under 6 foot long, and maybe the lighter one of the two, I think, is between 30 and 40 pounds. That one there, I think when fully kitted out, was between 80 and 90 pounds.
Wow. So large parts, and you've got to get them through what you call safe launch. I knew it when I was at
Yes.
General Motors, we called it PPAP, a production part
Yes.
approval process. But
Yep.
basically prove to the OEM you can build them without creating errors, right? So you've got, 30 factorial ways to mess it up internal to each
Yes.
one.
Yes,
and
absolutely.
how to produce them at high volume with no errors getting through. Okay. That sums up safe launch pretty much. It's basically
Yep.
prove it. Time to prove it. Okay. And then what was holding you back?
The biggest hurdle we had was just originally was the lack of work instructions, taking a non-skilled workforce and basically just saying, okay, hey, here we go. Now we need to make 2,000 of the left hand, 2,000 of the right hand without any problems. And parts got missed. Like you said, there was over 30 pieces that went on this. It was very easy to miss something. I mean, I know I did it myself, just messing around, and it's like, oh, yep, got to do that one. It's very easy, and especially when you start getting in the just doing one right after another, after another, after another. It is very easy to make a mistake. And we had our paper books, which you can see as an example there. That's not a fast. Yeah, it's not a fast process to, okay, let me open the book, let me look at the book, read, okay, I've got to do this, I've got to do this, okay, let me turn the page. It's, let me hold the book or have the book in a area that I can get to it. It's cumbersome. I can attest for that.
Well, we see it across a lot of different factories. I call it industrial tourism. It's kind of an interesting portion of my role now. But there's two things that jump out from what you were saying, and I'll ask to see if I can get it correctly. But one of them, I call it the jigsaw puzzle problem. I like to do jigsaw puzzles with my family. So 1,000-piece jigsaw puzzle, find all the edge pieces when you dump the box out so you can get started. What are the odds of you staring at something day in and day out and finding every one of those edge pieces on the first sort, right? Staring at these aluminum parts with, spacers added and nut certs and things like that don't have positive feedback from a machine or a piece of equipment, and you're asking the operator to do that day in and day out without making a mistake. I think asking people to be perfect isn't very realistic, in my opinion. And then the second piece of the puzzle is, the documentation is really what this is, as opposed to guidance of a worker on each and every step. I know that that's they're similar and related to each other, but at the end of the day, when you write it on a piece of paper, you have to show everything that you can think of that they might ask, they might need to know in order for it to be fully documented, as opposed to an experienced worker's guidance is more about reminders over time. And I think that's one of the other issues with these types of paper instructions that people tend to get into is the engineer fully documents it, but the operator only needs to know a high level series of reminders when they're doing the job, not after they exit training. So, well, I obviously work at Pico, so I'm biased.
Right.
But tell us about how safe launch actually went once we had the system in place, how long it took to get it in place, and the other side of it.
I think to get it in place to where we were happy with all of our work instructions, we probably had a week or two in setting it up, between getting the hardware around, taking all the pictures, getting them uploaded, getting it built out. And then in our situation, not only having it in English, but then having it in Spanish as well.
And doing your day job at the time.
Yes. Yes. Pico is not my day job. I wear many other hats throughout the day. So yes, it was trying to allocate enough time that okay, this is a high priority. But then anything else that would interrupt or take away my attention, trying to deal with that as well. So once we got it set up and in place and we're happy with it, we passed our safe launch in like 2 weeks. It helped so much because now it's up on a screen in front of the operator. They can see, okay, hey, I'm on this step. Here's what I need to do. It's telling me I've got to grab these, 6 riv nuts and put them in, these 6 locations. And then once I do that, I've got a little button I hit that says, yes, I did this. On to the next step.
And the right information at the right time is key, regardless of the system being used. So for those following around considering other options, that's just the thing that this does at its core. We like the UI at Pico, user interface, and the way that it presents the information. It's IoT enabled, so it can auto advance if there's an input to do so. But at the end of the day, it's just about having the information sitting in front of the person so they don't have to guess, as a reminder or as a cue to move forward, and then doing it in the easiest possible way, the most sustainable way over time. So I think it's interesting. Any other comments you wanted to make about kind of the safe launch experience? I think the reason this matters to me is just that, I mean, between my time and the 2 first OEMs I worked with, we probably PPAP'd hundreds of suppliers for sure. And it's interesting because with the volume runs, it was 300 unit minimum at GM. I think we ran slightly less or slightly more at Tesla, depending on the part we were setting up. But there's so many opportunities for error that if one little thing gets through, you start over.
Yep.
So
Yep.
being able to show how technology can help pass that, because the other dirty little secret of automotive is they don't come back, right? As long as you don't make another mistake.
Right.
This is a one-time event for the most part, but yeah. But yeah, any other final comments before I click forward, or I want to talk about
No,
what's
I
new?
don't. Yeah, let's talk about what's new.
All right. So I think one of the interesting things on these is it's not a one-time stop whenever you're transforming a factory, right? It's a journey. They call it
Correct.
continuous improvement, not random or so it's a biannual improvement. And so as we move forward, we're always developing new features. There are other software technologies on the market. Everything is kind of more IoT enabled tools coming together. But one of the things that I think has been interesting for us to see anyway is managing high mix environments. And so you would live in that environment on a daily basis, right?
Yes.
Some of the automotive stuff is more stable than the aerospace, but we released this process variance function. And for those that may not be familiar with it, the idea here is by creating a template process, and this is Pico's UI, so if you've never used Pico, it may not make a ton of sense, but this is a 6-step process and has a lot of torque actions and a couple machine connections. But the idea here is that you could build a lot of products with very similar processes and then just tweak them, maybe call for a different torque value, or how the barcode might read a different part number to produce a different variant or configuration of the part. So we do this in a way where anything that isn't different can stay linked back to a template. So update the template, it updates all of the variants. And for things that are unique, they stay unique and you can drive them as such. But talk about how you use variants and how that kind of manifests inside of Pollington.
So the first way we started using variants, we had basically 2 different variants we'd go with, either right hand, left hand, or in the situation of this, English and Spanish. So we built out the one template, and it was in English since that's what I read and speak. And then from that, we make the split. Okay, left hand, right hand, left hand Spanish, right hand Spanish. And it made it very easy that, like you said, we just either only had to change a couple values or turn some pages on for left hand and some pages on for right hand, or vice versa. But this way you're not trying to basically reinvent the wheel every single time. We start off with the one template, get everything you need, then tweak from there. Or if now you have, hey, this value now is different, or this part's changed, well, you go into the template, make the change there, and it's going to carry through to the corresponding variants. So that in itself is just, it's a huge time saver once you've got Pico up and running. Once you're established in your thing that, oh, hey, there was a revision change and now we have to do this instead.
Yep. And so no, go ahead, finish your thought.
I'd say, yeah, much easier to update that than previously when we were using the paper books to have to go through and update all those.
I was going to say, yeah, the key, so, you get what, 15 minutes, maybe a half an hour to make an update between meetings and the next firefight. And
yes,
if all change the image once, for example, to show whatever it might be, if it propagates to all the variants immediately, which is how this works, because the only difference between the English and the Spanish is the text box. So the image stays the same. The text areas are what changes. On other variants, it might be just the action, the scan part number or something like that. But it subdivides a given step. And then as far as making revisions over time, we had a question come in that was about backwards traceability and kind of what we mean by that. So every build is tracked against its revision of the work instructions that are used. So if you go from version 5 to version 6 on serial number 17 versus serial number 18, it knows exactly when that changed. How many revisions do you think you've pushed in a year, if ballpark?
Several.
Yeah.
That across everything, in a year, I would say at least 50, if not closer to 100, because it could just be once I get everything set up in place. Oh, I don't like the language of this a little bit, or I want to clean this up, or I want to get a slightly better picture, or any of that. Yeah.
Operator asks a question, never answer it twice. But yeah, and then so how does that work with the trace side of the house? So if I pull a part out of the OEM facility that was built 6 months ago and give you its serial number, what happens from there inside of Pollington? So
if you give me the serial number, I can plug it in and I can see every single thing that was done with that part at every single station. So that's the fun thing. The assembly that's being displayed in the picture, there are several steps of machining before it even gets to the assembly process. So if I have the entire serial number of the assembly, I can say, okay, well, now I see it has an inner and outer and a spacer, and I can see exactly of those 3 parts, the individual serial numbers for those, to see, okay, hey, these parts were machined on this day on this machine by this operator. We've got the traceability tells us everything. And then I can see, okay, hey, this is, oh, this part was an older revision, or this part's the current revision. Yeah, everything is, you everything about the part.
And that's just through barcode scans to be able to collect that information.
Yes.
Yep. And then,
Correct.
So Pico then ties it all together based on what we call internally our trace tool. So, and here, I guess this is kind of where we were heading with that. So the work instructions call out what to do, and then the IoT tools are what is used. Either, I guess you could technically manually enter them as well, but
yeah, you could.
You run the risk of a mistype. But yeah, and then are you printing these labels in-house prior to the laser engraver coming online? We'll talk about in a minute.
Yes. The only, in that picture on the right, there's actually a really large label on top of it. That was, so we would send out the components, had them friction stir welded, they would come back to us. We actually had our supplier just throw a big label on that they were using their internal way of saying, okay, hey, this was stir welded on this date. Here we're giving it a serial number of our own. And so we would then scan that in as well into Pico, and it, Pico didn't know any history on it, but it was able to keep track of it and ultimately tie it to the assembly. So again, if we had a problem, we could contact our customer that was doing the stir welding and say, hey, we noticed on this one here at this day, we running into an issue.
And so whether it's, so I think that's a very interesting point to call out, because I think you do this on the raw extrusions coming in as well, right? And that's a lock code track, correct?
Yes, correct.
And so for that one, you might have 50 pieces against the same lock code, but then they become serialized farther downstream. And then as it goes out for friction stir or passivation or whatever it might be, simply by capturing the label from that vendor, you now have their record keeping associated all in the same system. Well, this shouldn't be hard. At the end of the day, I could do this with a spreadsheet. It just takes a lot of time to type it all in, right? You're just literally recording a bunch of values over time. And I think that's the magic of Pico, or why a instruction IoT combo becomes really interesting, is because you can guide them to it very easily. First of all, you have to say to do it, you document it, standard work. And then you just make it brick simple to actually collect the information. There's some tricks in Pico. I don't know if you ever bumped into them, by the way, but we even do what we call variable transfer. So imagine you have 50 parts from the same lot. You don't want to have to scan it over and over and over and over again. We can look for a change, which is kind of a neat thing that you might not have experienced in this type of manufacturing, but others would, where instead of asking the operator to scan the same lot code every time, imagine a stack of 50 extrusions, you scan it once and it's associated with all the builds until you scan the next one. And it's kind of a neat way to go through that, but it reminded me of it. So
yeah, we haven't done that one yet.
Yeah. What about your quality checks? Because one thing that I've seen in all the machine shops and casting facilities is, you're not gonna you have 100% inspections, but you also have to go in depth, whether it's on a CMM or through a gauging system. How does inspection work at Pollington, and where are you kind of heading with it within your data traceability journey?
Yeah. So originally quality, we do, like you said, we have a CMM, and we keep records of the parts that are scanned with that, but that data never really made it back into our traceability side of it. And the CMM side of stuff that's going to be one of our upcoming things, is tying that into Pico. But everything was done on paper for like our 100% inspection. They're writing down for the safe launch. Yep, we checked, here's the serial number of this part. Yep, we checked all this. We started using the quality system in Pico and kind of build out all of our quality checks. And the simple way that we kind of do it we call it 100% inspection. And it's backwards. It's not inspecting 100% of the features on the part. It's inspecting 100% of the parts. So we've got one, it just goes on a gauge, and then it has 2 pin checks on that gauge. Did it pass? Did it not pass? So they are scanning the part when they start, and then they do their gauge check. And if it's successful, I've got a little QR code sticker that I printed out and stuck on the gauge, and they literally just scan the sticker that says pass. And then it knows, hey, I passed that. Into our hourly or the daily check, there's more in depth. So again, this was built using the template and variant system, that the hourly checks, okay, now we've added 8 more checks. So those are just turned on for the hourly, and it's, did this gauge work on it? Did this gauge work on it? Measure this. Is this within here? And then the daily is a first piece, the first part of each shift. They measure, they've got the calipers, they measure pretty much every machine to feature on the part, and they enter it into Pico. And it's nice because if we have something that fails, we can actually scrap it right out through Pico, and then Pico knows, hey, this part was scrapped. It keeps track of it. It's worked very nice. We don't have our quality engineer at the end of the month now in Excel making a spreadsheet, counting up, okay, here were all of our scrap parts. At any given time, we can pull up and look and see, okay, hey, what was scrapped? Why was it scrapped? the operator right from the screen can say, hey, this was scrapped, tool broke, messed the part up.
Yeah, I like that. So for some of the details behind that, the users can create custom what we call notes, but they're, whether it's a quality ticket or a process improvement, there's different categories of them, and then they're in the customer's language. So if for you in a machine shop, you have broken tool caused damage, it's tap, tap, and done. And then some of the other fun features on this. So let's say how many total inspection points on these parts? Maybe 30 for the daily, something like that.
Yeah, there's quite a few.
So you make 30 steps in one template, and then you leave
Yep.
them all on for the daily. For the hourly, you turn off 22 of them. It's just clicking check boxes and then hitting exclude. And then for the 100%, the one you do on every part was 2, 3, something like that.
It's just one. It's pretty
Just
much
one.
just,
They're even easier.
Yeah. Yep. It's did it pass on the gauge. So they they just scan it to basically, you can see their scan incoming part, and then step 2 being process serial number. And that happens. That happens without them really seeing it. It's just as soon as they scan it, it's already passed the process serial number, because it's just the step of saying, okay, I took this big long group of data that's in this 2D matrix, because it contains more than just the serial number in that, but it's looking just for the serial number. It doesn't care about anything else. And then the next step is, did it pass the gauge or not? And they just scan pass if it did.
Just think about what you just rattled off and how sophisticated that truly is. And then yet how easy it was. So you have a 64 character, I don't even know how long the part number this OEM requires. It's got several pieces of information in it. You use that to start the process, right? The operator doesn't tap a screen, doesn't do anything for the daily, right?
Correct.
So you grab certain characters out of it through what's called a parsing function, but it says, give me characters 7 through 11 or whatever they are. That is used to look up which process to start based on its part number. And then it captures a different set of characters for its serial number, along with the full string, all automatically. So the operator goes beep, beep, gauge fits, click, beep, done. So you add in, wait, let me ask the question slightly differently. What takes longer, doing all those scans or writing down they passed in the Excel on the piece of paper?
Oh yeah. Writing down that it passed, and then being like, oh, where did I set my pen? I thought I had it right here. Oh, it fell on the floor. Yeah. Wow. It literally, it takes just seconds. They put it up on the gauge, they flip down the couple things, check the pins. Yup, it worked. Scan and I've got the sticker is literally right on the gauge. So, I mean, everything is right there.
And it's using the same scanner they were already using at the CNC machine. So it was already so no hardware on that. And and there's a extra screen available on a tablet if they need it to look at something for the hourlies and the dailies. Yeah, so it costs you $150 for a tablet. That's pretty. I'm sorry I get lost, and I know we sell this stuff, but I still think it's neat. So
oh, it is absolutely. No, and the operators think it's neat too. They are so happy that they don't have to log all this stuff and write it all down. It's you ask any one of them, hey, do you like having to write all this stuff down? And they're going to tell you absolutely not. So yeah, when we propose, it sounds like, oh, well, you're adding more work. It's like, yeah, but not really. Even if it did add a couple more steps, the amount of time it saves the operator and just the ease on them, and they don't have to make sure they write it down right, that they write the letters right, or somebody can read their handwriting, or it's just everything's digital.
It's the reason I think why we went down this journey of IoT plus instructions into one platform, but is for those that may not be familiar with this portion of Pico, but we have over 200 families of connected tools. Like Kepware is one family, Detected is one family, right? These are all Keyence laser engravers are one family. And so every single thing in this library was added because the customer asked us to solve a problem, either to collect data, to error-proof a process, or to improve the efficiency, period. That's it. And it costs the supplier How much does it cost for you to add a commercially available device to this library, Chris?
It doesn't cost us anything other than
$0.
just,
It's my
yep, yep, just buying the equipment. But yeah,
Yeah.
you know, I just say to you guys, hey, I've got this tool. I'd like to have it work in Pico, and you just say, okay.
It's a pet peeve of mine because I feel like it's the software's burden to integrate the tool, not
Mhm.
not yours. I mean, that's because we're
Right.
software engineers. We're supposed to know how to
Yeah.
do this,
Mhm.
and we can make it go faster. And so the idea is, I know no one's going to use all of these. Are you kidding me? What factory could possibly use every single device? But having them available, it's, you know, we call it the candy store internally. It just
Mhm.
allows people to solve problem or know that they can. Even if
Yeah.
like we have lots of customers that never even use the IoT library at all. They just haven't gotten there, but they know they can in the future, and that's
Mhm.
an important feature. So, well, tell us some about the devices you've integrated lately, because I think I'm seeing your sophistication grow rapidly from you know,
Right.
a binder-based instruction system with nothing on the shop floor, just operators and muscle memory, now to a connected
Mhm.
experience with full traceability. What comes
Yep.
after that?
Yep. So the laser marker was a solution to a problem we've got one of our assemblies that we can't use a label on. The part
A
gets
paper label. Yeah.
yes, a paper label. The part gets passivated, and the paper label just isn't going to hold up through that. So originally we were using a dot peen to basically engrave in, you know, hammer in the little markings on the part for a serial number and the date that it was manufactured. And not only is that slow, but it's just ridiculously loud, especially on these long hollow aluminum extrusions. It was deafening in the shop.
World's
Um,
loudest woodpecker.
Pretty much. And not only, and you have several of them going off at any given time. It was very unpleasant to be around. But then it's not necessarily the most reliable. It's a little hard to read, and you're relying on the operators not messing up the program. Or when we get a new bundle and okay, well, I've got to go in and change the lot information, and that happened several times that they would either put some information in wrong or delete the program. I can't tell you how many times I would get a text on my drive to work saying, hey, they messed the program up again. And it's like, great, I'm going to deal with that when I get there. Um,
Straight to firefighting mode.
yes, yes. So that's the laser marker was the solution to the dot peen program. It laser marks on there. We've got some human readable information. So the part number, serial number, date, time, that's all human readable. And then in a 2D matrix, it has what the vendor required. So pretty much all of that and more in that 2D matrix. And it did it in I think like 20 seconds maybe. And Pico is sending the information to that laser marker saying, hey, here's what needs to be on there. Um, and so the operator just has to take now and scan the barcode that's on that's got the lot information. They just scan that, and that's loaded right into Pico, and it says, okay, I know what I need to do with this information. They've got the assembly in, they make sure it's locked in place, and as long as the two proc switches are met on the safety for it, they just say, yep, it's good. And Pico tells the laser, okay, hey, put this on there. And then once it's done, we just scan it to record it in.
Yep. And that's just
Oh.
an action on a step, right? So for the
Mm-hmm.
paper labels, it's a print action.
Mm-hmm.
I think we had a question come in, but the way that works is you create your label, what we call a template file, in
Yep.
either like Zebra Designer is the most common. You can use it Brothers, there's Brady's, Dymo printers, things like that. But they use the label company's software to create the label because that's who's good at doing that. We save that in Pico. You can overwrite, like if you put in the word serial number, we overwrite that with a scanned in value or an automatically generated serial number value into the template. And then as far as the operator is concerned, when the system advances to the print step, it automatically triggers the printer and it just moves forward. It's like bang, bang. Easter egg. I don't know if I ever showed you, Chris, but internally we print the labels for our edge device. The only hardware Pico provides are the edge devices. I use a picture of my dog as the picture on that particular step. Nobody ever sees it
Oh,
because it
nice.
passes right
Right.
through it. But fun
Yep.
chance to do an Easter egg if you want. See if the operators
Right.
notice. But
Nice.
laser engravers work the same way with a slightly different template file. But I think a key to traceability, you have to think about it on both sides. You have to be able to generate the thing that is on the part so that it can be labeled, like, and in that you have the ability to keep track of it. If you have 5 pieces in front of you, you need some way to be able to see which one is which. So we have a script that generates a serial number. You can format it to your kind of these characters or static text, this one increments, whatever it might be. And then the other side of it is you need to be able to mark the part, or if the part's already marked, it's easy. You just scan in their serial number. But to mark a part, it's usually either a paper label or a laser. There are some new technologies coming with microscopic cameras where they can actually look at the grain structure of a part and supposedly identify it. We'll see if it comes to fruition or not, but that would be great because you wouldn't even have to mark it. But I will mention one thing before we get to the detected part. And by the way, Pico doesn't sell this hardware. Again, this is just our job to integrate it. So you guys picked this. But I thought you did a really clever thing about where you put it. So if you marked the parts at the CNC machines, you would need a laser engraver at every CNC machine. But you all have a CNC saw, right? So you bring in, correct me if I'm wrong, you bring in a 20-foot long, what they call lineal, a big long extrusion, and it gets cut down to a shorter length before it goes to the machines. Is that correct?
Almost. So
almost, okay.
The lineal, it isn't that long. We get it from the extruder, and we've had them leave I think like 4 or 5 inches on, because we square it up ourselves, and then the other end gets a mitered cut. So
interesting.
And yes, and these are both happen at the same time. So then but we do that at the saw, and then it comes off the saw, and right next to it we've got a table with the Pico station set up, and the laser engraver, and the operator. So once it's cut, he pops it in there, scans it, and says, "Hey, mark this." Then while it's marking that, he goes and grabs the next part, puts it in the saw, starts the saw, then the 2 or 3 steps over to the Pico station, pops that out, and puts it on the pallet. We originally wanted to try to incorporate the laser in the saw, but it being a fiber laser and the whole trying to enclose it so the laser isn't visible at all was a bit of a headache. And it's like, well, we'll just put it next to it. Little cleaner,
safety first.
Yes. And it's worked out pretty well.
What I like about it is because you did it at the first time you touched the part. Now everything downstream is fully traced. Had you done it a step or 2 later, you would either need a lot more of them, or you would miss early integrations of data. Basically, what are the odds you care about when it came off the saw? It's probably pretty low, but you have it just in case, and it didn't cost you anything.
Exactly.
And now any other part for any other OEM or any other project coming along can take advantage of that. I thought that was really clever. So, well, let's switch over to the other one, because I think, AI, visual AI and things like that is a really interesting technology for certain applications. And you happen to have a perfect application, which is you've got to put a lot of things into a large part that isn't conducive to what I'll call traditional inputs. So think you're not shooting bolts. There's no bolts involved in this, right? So there's no opportunity for a DC torque tool to provide results. There's not a consistent way to fixture it that would allow you to use proximity sensors or something like that without screwing up the operator experience.
Right.
So a camera-based system makes a lot of sense when you're trying to figure out, did I get every nut clip? Did I put every spacer in? So you chose Detect It. How did it go? And what does it do for you?
It's gone really well, actually. As for what it does, it basically just kind of watches the part. We have on this assembly, we actually have 4 cameras watching the part because throughout their assembly process, they end up spinning the part around, rotating the part. Things go on all 4 sides of the part. And the part is in just a loose state on these assembly tables. So it's, your traditional vision system just wouldn't work. As they're assembling it, they're kind of sliding the part around a little bit. They're moving it. And so what the Detect It does is between the 4 cameras, they're just, because the part is so long, they're just positioned, 1, 2, 3, 4 throughout the length of the part. And it's watching things. These pictures here on the slide are when Detect It sees that everything is good and Pico is looking for Detect It to say everything is good, it'll save a picture also. So these, unfortunately, the pictures are successful detects. I don't have one where it's a partial because it's not saving that. But the top one here, it's looking for the 6 yellow crush tubes that go on this assembly. We've got yellow ones and black ones because they're 2 different lengths. So we just paint the top of them, and Detect It knows if I were to try to take one of the black ones and put it instead of a yellow one, it's not going to say there's 6. It's only going to have 5 of those lit up until the 6th one is in place. And then Detect It would say, yep, the 6 are here. Pico's on the step of, okay, I'm waiting to see that there's 6 yellow ones. And as soon as it sees it, it's on to the next step. The operator doesn't have to interact with it other than just putting the tubes in. They don't have to tell Pico, okay, yep, I did this. It just, as soon as it sees it, it snaps the picture and it's on to the next step. Very, very cool process.
And you mentioned you didn't have any pictures of 5 of them installed instead of 6, but that's because
correct.
it literally cannot advance
No.
with 5. It will not allow it to. So
Nope.
it's, yes. And that's error proofing to me. It's a hard stop that the system can do. So your only risk here is that there's one there and it thinks it's not what they call a false negative.
Right.
So
and
interesting.
Yeah, and so we had to basically train Detect It. So we did several recordings of the operators doing each step. And then in the Detect It software, okay, this is what you're looking for. This is a good one. We built some that were bad ones. Build them kind of in different directions a little bit, turn them a little bit, lighting condition a little bit different. So it had everything to compare against.
Interesting. Well, I saw a question come in and I'll answer both of them real quickly, but there was a question about what a Pico station is. It's just a station where Pico is deployed. So there is a screen. Pico runs in a Chrome browser, so you can use a Samsung tablet, you could use a hardened tablet, you could use a touchscreen monitor. I think you guys use touchscreens for the most part, right, Chris?
Yep. Yes.
Just Acer, Amazon specials. Yeah, $200, driven by one of our hubs. You can run it on a laptop if you already have one, or a desktop. Just anything that can run a Chrome browser is a Pico station. And then as far as the hardware goes that's associated with that, it's just whatever you add. So you could add a scan tool, a printer, a laser engraver, whatever is needed at that station. It's the physical place where work is done. So I hope that helps on the station definition. And then correct me if I'm wrong, you're using ELP cameras, 2 megapixels for the Detect It system,
correct.
right? The USB, USB driven back to their processor units.
Yes.
So, for the camera question, and then as far as the presentation later, I'll let Shayna and others cover that at the end. But yes, I believe we share it. Well, this is, I think what's really neat here is, so if you ever had to install rivets and riv nuts, there are ways that we can pick up some amount of coverage with these. On a rivet, you can take a regular rivet tool and try to catch when the tail of the rivet falls off the back. You can put a brake beam sensor there. There are some smart tools that look for the tail to come off, but it still doesn't know if you just pulled the trigger in the air, if you put it in the right spot, right? That part of the error proofing is really difficult. On a riv nut, your choice is $25,000 a pop or more for a smart riv nut tool versus the $3,000 air-powered ones that traditionally do it. We can tell that a riv nut was collapsed by monitoring a pressure sensor on the back of the air-powered can. Basically, when you pull the trigger on it, it creates a ripple in the pressure line, but it still also doesn't know that you pulled the trigger in the air or put it in the right spot. So there's some nuances. Still better than nothing, way better than blind coverage, but not as strong as this camera system. This thing has its weaknesses too, in some ways, right? It can think a riv nut was installed, for example, because it's loosely in there. Flip it over, it falls out. In which case, the combination is the best. What I like about the detected example, or whatever the technology is, error proofing is as far as you want to go, and it's about coverage. And sometimes you need multiple levels of coverage to get there, and it's our job to make sure we layer those as needed. So if for some reason we had to put a rivet tail detecting system in as well as detect it, or a nut pressure sensor system as well as it, then we can, and we would support that. But if the camera picks it up and it's at the acceptable level, then great, move forward. But there's all that kind of PFMEA stuff. So I know we're going to try to wrap it up real quick, but how about 1 minute on where you're going from there, right? So you're a year and a half into this and it never stops. It's always going forward.
Right.
So
Yep, it is. It is. I think going forward, as you can see on there, monitoring scrap rate and cycle time. So we've been on one of our assemblies. We're not relying on the operator to say, "Yep, I did this part." They scan the part, put it in the machine, and when they hit the start button on the machine, Pico is already looking for that. And as soon as they hit the start button, Pico says, "Okay, we're off, we're running." And it knows it'll then get a signal too once they've finished running the part. So we start to see cycle time of, okay, how long they have to scan the part to get anything to start. How long does it take them to pick the part up and put it in the machine? Or how much time are we seeing between this part's finished and they've started the next part? Or, hey, we're running this part on 4 machines. It should be the same program. Why do we have one machine that takes it a minute longer to machine the part than the other 3?
Yeah, the uptime and we call it death by 1,000 cuts, but if you're going to pick up 10%, you're going to find it 1% at a time, 10 times, or maybe even less, more times. So that visibility coming off from the trace tools actually also shows you your idle time between cycles, as well as load unload, technique validation, if you want to think of it that way. And then in the program at a high level, it's cycle times as well, but there's other methods for getting that. And it just makes it very visible. So interesting. Yeah, I think I'm excited to see where you go with it. I did want to make sure we get to the next phase of this because it's something we do that others don't. And I think it's very important, which is, here's where the rubber meets the road. What did it cost? And so for those following along in the background, this is the transparency that we try to achieve. But it's roughly a $12 million a year revenue project with 1.5 engineers part of their time. I always laugh at that. It's like, pretty sure your entire headcount isn't dedicated to rolling this out, although I'm sure it would be fun.
Yeah.
But here's some rough costs. The AI-driven camera system for 2 different, for all of the, you have multiple cameras, like 8 total, multiple GPUs. That's around 60 grand one time. Keyence laser aren't cheap with the fixturing and the safety systems. It's about 50,000. Assembly fixtures for the tables and everything. So, in hardware total, 163,000 is the ballpark number. I think that this roughly costs to get set up. For Pico's costs, with the number of stations they have, it's roughly 60 grand a year. So probably half or less of the cost of an engineer in exchange for all the traceability technology and then the efficiency gains that come from it. The journey is kind of shown. You can see how they moved different over time, added more and more stations and adding CNC connections, but it's a journey. So
Yeah.
Important. And then we've got 10 minutes. So how about let's start hitting some of these questions. You up for it, Chris?
Yeah, absolutely.
Okay. So we'll try to go quick because there's some in the chat as well. But legacy-minded OT engineers on board with a more integrated approach. Yeah, how did the culture shift at a family-owned small factory somewhere in the middle? I forget which hand to do in Michigan. How'd it go?
It went. We had quite a bit of support. We've always said, well, here's where we're at. What's it going to take to get to the next level? Just because if we don't get to the next level, our competitors will. So that's been pretty helpful, that we've always had quite a bit of support. We did have a holdout from the older way of doing things, but luckily he just retired, so that made it easier there.
The easy way to get around it,
right?
What's it like working with Pico for customer support besides having to deal with me, from time to time?
It's been very, very easy and pleasant. Working with you guys has been really easy, and especially since a lot of you have a manufacturing background, so you kind of get where we're coming from with questions. So that's
the average response time. So if you need something's down, something's happening, how long before? What would you expect before you have somebody engaged on the other side?
I guess it depends on how serious the problem is. If it's a serious problem, it's usually less than 10 minutes. And I guess it kind of just depends on when I post the question. But yeah, if it's something that's like, oh, hey, this is on fire, within a couple minutes, I've usually got a response. There's other things that I'll just throw out in the Teams channel, be like, hey, here's a question I have, but I don't need an answer this moment. Just, get to it when you can. And, something like that if I have stressed that this is not important, maybe an hour. And
that's because you have a shared Teams channel with our team, correct? Yep.
Yes. Okay. Yep. Absolutely.
I think we covered how big your quote unquote digital transformation team is, but that's you and Brian, right?
Yeah. Me. So. And then Brian some of the time.
Yeah. How flexible for different industries with different QMS requirements? That's probably more for me. Depends on how you define a QMS. So Pico typically will integrate, I think that's probably best handled outside of here, but we integrate with some QMS systems through ticket generation. So an operator can go through what we call a note, but just simply say, hey, I have this problem, and here is maybe some text or an image to describe it. We send that to an external system via REST API typically, and then it comes back for closure. As far as the Pico versions of QMS, where we have the error proofing and some of those kind of inspection-based systems, I think we're really strong in aerospace and automotive and their requirements. So think like IATF level of requirements and the AS9100D. In med device, pretty good. All of that lines up as well. There are portions of food and bev and internal to the body certifications that I think we're still working through or are waiting for enough of a demand to do so. So there's some nuance in there depending on the industry, but we do see a lot because of the number of facilities that we work with in those industries. Connected older machines. I don't think we've connected any older machines in your factory, right, Chris? Just your Mazaks all run MT Connect. So
correct, yeah.
In other facilities, we typically add sensors to get information. Sometimes it's monitoring the stack lights. If it is a machine, that's an easy way to tell on, off, alarmed, and waiting. Door switches and safety switches are great for when the operator is present. I know we did update your air tools with a pressure transducer so we could see when you used rib nuts, for example. It's kind of a legacy integration. So yes, but it is case by case. That's the way it works. But we do have a big old bag of tricks for different things we can gain from it. For you, Chris, how important is plug and play capability when you're deciding on new tools or systems? Do you guys have IT support? Can you generate your own integrations?
It's we can't really generate our own integrations easily. We do have some IT support, but usually if we see that it's any form of a smart tool at all, I pretty much just kind of bring it to you guys like, here's this, make it work. If it doesn't have smart tool integration, I still say, hey, can you make this work? I guess it changes from being a demand to a question. It's rather than going from make this work to can you make this work? But I do have faith that especially anything that's plug and play, I know you guys will figure it out.
Yeah, and so I think for the reality is it needs to be because of the time constraints for you all.
Yes.
Different teams have different sophistication levels. We have other teams with maybe in-house ignition resources and things like that we might do a different style of back and forth. We have people who do custom scripting, and then we integrate with their ins and outs, LabVIEW, stuff like that. So interesting. Well, I like this one. I'm going to actually answer the one in the chat first, which is how does the operator know when they're supposed to build next? Is there a queue, prioritized advanced planning, scheduling, et cetera? There is sequencing. So if you're at a single station that does multiple processes in a row, you can have it build the next process in the workflow for that given serial number. So you can run sequences like that. We do connect to ERPs and work order systems. So that runs what we call FIFO with exception. So first in, first out in the sequence we receive the order, and then you can manually intervene both at the operator level or in the scheduling level to rearrange it. We are not an advanced planning or scheduling system. So we don't do like AI-driven tools for MRP level of functionality. That's typically an external system that we would integrate with. And then finally, all right, 3 minutes, Chris. You had it to do over again. What advice would you have? What would you say to a team that's trying to follow
along? I would say just make sure you've got a good roadmap of where you think you want to end up. And it's okay if you don't end up necessarily there. I know there's been a handful of things that as we've grown and added on, I've had to kind of do over a little bit just because I didn't realize, oh, hey, we're going to be doing this as well. So for the sake of making the data easy to see or keep track of or naming tools, kind of that's the one area because, I had no MES experience coming into it. So that was just something I didn't give it any thought to.
Yeah, I think a roadmap or like known problems you want to solve, depending on how you want to view it, is important. I also would like folks to think about, I call it doing the math, but most facilities need some form of business case or a reason to allocate resources towards it, right? If we go back a couple of slides, this isn't free, right? You guys put in, yes, this is a pretty big project and it had, therefore CapEx associated with it. But if you can, that you can take 2 zeros off of this and still get started on both of these. Hell, we have a free version of Pico that you can use for small teams with work instructions. It's on our website. The idea though is, if you can put a dollar amount next to the problem. So we have issues with training and onboarding new people. Okay, well, how much of the supervisor's time is spent? How long before they get to rate? What does that cost in either excess labor or lost production? If anything that can get a dollar amount to it will help the executives understand is this an infrastructure improvement and we need a CapEx budget for it? And, they can either rearrange to support it quicker or it'll have to happen the next year. Or is this an operational expense where by putting this in, we will make more money, we will save on labor, we will produce more parts, we can take on a new project, whatever that might be, which has a dollar amount to it. We're pretty good at doing it at this side, but it's just getting the team to start thinking about things like if we made 50 parts today, 60 parts the next day, back to 50, then at 58, then at 40. Well, technically everything below that 60 that you had, because that in theory is possible because you did it, those are all losses and there's dollars for that. And if you don't track it, at least in a spot check, it's hard to justify why you want to fix it. So that's what I would encourage teams to do. Okay, right at the hour. Shayna, I'm going to kick it back to you. Chris, thank you so much. This was fun.
Yeah,
I haven't
thanks,
got to
Ryan.
see you in a while. So
Yeah.
Yeah, thank you, Chris. Thank you, Ryan. And thanks everyone for investing some of your Wednesday to spend some time with us to learn about how Pollington and Pico work together. So we appreciate you being here. As soon as I end the webinar, there's going to be a really short 2-question survey that pops up. We really appreciate if you guys could fill that out. It helps us develop meaningful content for future webinars. So thanks again for joining us. This will be posted on the Pico webpage, and you'll get an email tomorrow or later this afternoon with a link to the recording. So it'll be available post-event. So thanks again, everyone.
thanks all.
Great, thanks.